to today's edition of Physics Online. Basically, today we're going to start talking about acceleration. Now, you remember from one of our previous videos, we talked about speed being the rate of change of distance and velocity being the vector form of speed. So velocity would be the rate of change of displacement. And now we've got the acceleration, which the definition of is the rate of change of velocity. Okay. And I'm already seeing an error on my screen. Hang on a minute. So acceleration would be the change in velocity, okay, divided by the time. So if you have an object that starts at 0 and speeds up to 5 meters per second, the change in velocity for that object would be 5. Okay. But what we've got here is a way to look at this where we have different symbols involved. And so this symbol here, delta, is the Greek letter delta, and it stands for change in. Okay, v is velocity, which is our vector form of speed, and t is time. Okay, and so this change in velocity delta v is the difference between the final speed and the starting speed of an object. Okay, so delta v is equal to final velocity take away initial velocity. Okay, and those are new symbols. That one's a new symbol there for initial velocity. Okay, it has the same unit as velocity. It's just the start velocity, and v is the final velocity. Okay, and so our overall equation for acceleration can be written as a is equal to v minus u over t. Okay. So a is v minus u over t because the acceleration of an object is its change in velocity divided by its time. Okay, so I've got a couple of worked examples we're going to go through that'll help you with this week's worksheet. So, worked example 1. A car is travelling at 5 meters per second, accelerates to 15 meters per second in a time of 5 seconds. Calculate the acceleration of the car. Okay, now first thing we do in all calculation questions is we write down what we know. Okay, and since this is a question that's going to be dealing with acceleration, a, v, u, t, I write down all of those down the side. Okay, and so we don't know the acceleration, we're trying to calculate that. V is the final speed, so that must be 15. U is the initial speed, that's 5. And t is time, and it says 5 seconds. So we write down our equation. A is equal to v minus u over t. Put our numbers in, and so it's going to be 15 take away 5 divided by 5, which is 15 take away 5 is 10. 10 over 5, which is 2 meters per second squared. Okay, this is the unit of acceleration. Okay, unit of acceleration, ms to the minus 2, or meters per second squared. Not too difficult. Let's have another worked example. So, now we have a car is travelling at 20 meters per second, brakes to a halt in a time of 4 seconds. What is the acceleration of the car? Alright, if we write down what we know down the side, a, v, u, t. We don't know the acceleration, that's what we're trying to find out. It says the car is travelling at 20 meters per second and brakes to a halt. So if it's travelling at 20 meters per second, that means that's the initial speed is 20 meters per second. But it's going to come to a halt, and it's not giving us any other speed. So that halt refers to it stopping, and the speed of anything when it stops is 0. So the final speed of this car must be 0 meters per second. And it took 4 seconds to do that. Okay, so we write down our equation. A equals v minus u over t. And so a is going to be equal to 0 take away 20 divided by 4. So it's minus 20 over 4, which is going to be minus 5 meters per second squared. Why is it minus? Some of you might have already twigged why it's minus, but in this case, a minus acceleration represents a deceleration. Okay, or a car slowing down, or an object slowing down. Okay, so that minus acceleration represents a deceleration. Okay, now this is a difficult equation to rearrange when you use it in that form. So the form we had on the first page, where we had A is equal to delta V over T, is easier to rearrange because you can put that in the triangle and learn how to rearrange it that way. Okay, because delta V will be there on the top. Then we have A, T, like that. If you enjoyed that, please like and subscribe.